Hi everyone, myself Sridevi, professor. In this video lecture, we are going to learn about Weiner filtering. First, we have to know the basics of Weiner filtering. So, the Weiner filter was proposed by Norbert Weiner in 1940. Its main purpose is to reduce the amount of noise in a signal. This is done by comparing the received signal with the estimation of a desired noiseless signal. And Weiner filter is not an adaptive filter as it assumes input to be stationary. This filtering takes a statistical approach to solve its goal. The goal of the filter is to remove the noise from a signal. Before implementation of the filter, it is assumed that the user knows the spectral properties of the original signal and noise. So, spectral properties like the power functions for both the original and noise. Power functions of original and noise should be known. Here, f of x comma y is the original signal, h of x comma y is the degradation function, g of x comma y is the degraded image, n of x comma y is the noise, and star is the convolution operation. Signal and the noise are both linear and stochastic process. The aim of this process is to have minimum mean square error, that is the difference between the original signal and the new signal should be as less as possible. The important features and the main advantage of this one is simple and easy to implement, effective when noise is negligible, useful when the degradation function is known effectively. The important equations involved in Weiner filtering in image processing is, considering we need to design the Weiner filter in frequency domain as W of u comma v. So Weiner filtering is an advanced image restoration technique which is used to recover an original image from a blurred and noisy image. It minimizes the mean square error between the restored image and original image. The Weiner formula is given as f of u comma v equal to h of u comma v into divided by into h of u comma v divided by 2 plus s of n of u comma v into s of f of u comma v into g of u comma v. So here some important image equations should be learned to understand the basic concepts of Weiner filter. So the working principle behind this Weiner filtering is convert the degraded image into the frequency domain using Fourier form, apply the Weiner filter formula, reduce the effect of noise and blur effect simultaneously, convert the result back to the spatial domain using inverse Fourier transform. So, while talking about the advantages, the main advantage of this one is reduces both blur and noise effect, produces better restoration than inverse filtering, works well even when noise is present. Limitations are it requires knowledge of noise statistics, computationally more complex than inverse filtering, and main implementation of this Weiner filter are available in both MATLAB and Python. These implementations can be used to perform analysis on images. So basically Weiner filter is an excellent filter when it comes to noise detection or de-blurring of images. A user can test the performance of the Weiner filter for different parameters to get the desired results. It is also used in stenographically process. It considers both degradation function and noise as a part of analysis of an image. These all are the main principles behind Vienna filter. Thank you for watching.